Oh, okay, there we go. Oh wait, let me. Hmm, there we go. Apparently, I left that running all night. Oh man, that was good. Okay, edit project settings. I thought it was under editor. Do-do-do. Okay, so I think if I hit play, it should just play, right? Yeah. Okay. Sweet. We hit an upper limit of how many characters we can have on the screen at the same time. Anyway, so what we want is to draw a line, a debug line. Now, I found something here on the third-party packages that looked really promising. Mhm. Unity Asset Store, debug. There was a debug thing here, and it was price of free. I found it this morning, I think. It was not, no, it was, might have been this one. Yeah, I think it was this one. Wow, you're here early. That's kind of interesting. I found this, and I'm gonna give this a try. It seems to be kind of what I'm looking for. We're gonna try it out. Ugh, sorry. Physics debug extension. This is what I wanted. How's your morning going? Chrono. Wow. It's 9:45 here, and I'm awake. Well, it is 9:46 here, and I am also awake. It should hopefully be a good day of I guess we're in the same time zone. Yeah. Oh, you're in Cali? Or wait, when you say CA, do you mean Canada or Cali? Okay, I had a feeling it was Cali, but you never know with these things. Because CA, we also use CA for California, for Canada. Okay, so oh wait, what? What? Now let's relaunch this. I ran the project literally all night. Like literally. I think I left it on last night when I called it a night and just left it running. I came in and I took one look at this and it was still red and I was like, "Wait, what?" That's not what's supposed to be happening. Okay, so we need debugs. So how does this debug work here? That's a really good link he's got there. Oh, I gotta say. Uh, no, that. Oh, wait. There's a wiki. Hmm. I, cool. Source code available here. Oh, on a GitLab. Something you don't see every day. I wish that he had generated docs though. Physics extension. Debug extensions. Oh, here we go. Debug square. Debug box. Do one-sided capsule. What the fuck is a one-sided capsule? This is not helpful. What is a one-sided capsule? Circle point. A point. Draw a point. Let's draw a debug point. No, actually, I want to draw the wire sphere. Sphere. That's actually what I want. Draw a wire sphere. Google being Google and not able to find anything anymore. It's so true. Let's do Royal Heart namespace Royal Rotary Heart lib physics extension dot physics debug. Sorry, then debug. Okay, so it's rotary heart dot lib dot physics extension dot physics dot physics dot debug. That was it, right? Physics debug extend. Oh, and then it's under debug extensions. Debug extension dot. Is that not it? Oh, here we go. Sphere cast. Draw. Why not just make them a method extension of debug? Uh, yeah, I don't know. If I jump into this and then I can jump to this, we can just jump to one of his here, physics type. What's he using here? Physics. Physics type dot single box. Capsule. Do. Where is it? Sphere. Sphere all. What? No, I wanted the wire sphere. That's what it was, right? Wire sphere. I think it's not there anymore. Uh, it's a check sphere now. Physics dot check sphere. But I really wanted a wire sphere. Whatever. Check sphere. Okay, so we've got the position, which is the hit dot position. Oh no, hit's a boolean, right? So it would be ray result dot position, and we could do that effectively. Then we can jump to the sphere. To see, we've got the position, the float, the preview condition. The preview condition, what? Preview condition none. I'd imagine that would be none. Ah. Hey, so can we do this? Damn it. I really wanted that to work. Oh, it's hit color, that's why. Maybe? Does this work? No. Okay, so all right, so we want that, and then we want hit condition, which is preview condition both. And then we've got the draw duration, which we'll say is 0. So we'll say 5. And then the hit color, and then wait, what? No. Is this actually doing a draw? Oh, this is doing an actual draw. Oh, this is all I wanted. There we go. Position. Oops. I just want this. I don't actually want like the extra stuff. Okay, so debug requires, what's this take? It takes a position, a color, a radius, a draw duration, and the preview thing. So if we say position will be ray result dot position, then the color will be green. Do radius we'll say is 0.5f. Draw duration will be 5.f. The preview, this will be the what is it? It's the preview condition. Oh, it defaults to that, and then draw depth is false, so we can just leave those out. There we go. And that should give me exactly what I'm looking for. At least in theory, red. Or should I switch these so red is hit and green is not? And then this wouldn't be that. This would be end position. Ray end. Can you actually do that though? Like actually like inject into the debug extension? I'm just strictly not familiar enough with C# to know whether or not you can do that. You can kind of do it in Python. You wouldn't want to do it in a production app? Okay. Yeah, no, this is I found my problem. So when you ever want a method for a vector3, you can just do vector3 dot method you want to run. Yeah, but can you add to vector3, right? Without it's a method extension. Wait, I've got to look into this. I need C# or Unity. Is this a Unity or C# thing? Unity method C#. Okay. Extension methods enable you to add methods to existing types without creating new derived types, recompiling, or otherwise modifying the original type. Extension methods are static methods, but they're called as if they were instances. Methods on the extension. Okay, wait. The following example shows how to call the standard query operator order by method on an array of integers. The expression in parenthesis is a lambda expression. Many standard query operators take lambda expressions as parameters, but this isn't a requirement for extension methods. For more information, see lambda expressions. That's fine. Sorry. Order by. Dot order. Oh. Well, is order by not part of int? array, int array, C sharp array, order by. Hmm. Array dot order by. Wait, so I'm confused. This looks like it's just order by. It looks like it's just part of an array, right? So this is just lambda being passed into order by. Is behind. It's fine. Don't worry about that. I using extension. Oh, okay, wait. Using extension methods. And it can be called from an application by using this syntax. Following namespace extensions, public class extension, method A, method A. Is never called. You can also run that on any vector 3. I'm going to have to play with it at some point. I don't know that adding these to the default debug stuff would be appropriate, though. I think it'd be inappropriate to do so. Just because if you're adding to it and multiple people have added to it, you could step on each other and you'd get very inconsistent results. So it makes for a plugin, it makes sense to have them not be like that. This makes sense as to like why I'm not hitting things. Also, it looks like I'm going the wrong way. Sorry. So the positions are not staying. They're not update. The positions don't update. So we don't have the current acting position of the wheels. Vehicle config. Oops, that's what we want. There's our vehicle entity, right? So if I come into here and I do a debug.log entity location. Oh, do I not have access to that? Would this be dot? No. Interesting. Okay, so this doesn't have the location. Okay. Uh, would you need to query each wheel? It kind of feels that way, yeah. Which I th- which might be why it was doing that like parent thing. Okay, so what are we doing here? Okay, if I come down here, each wheel, which this is the wheel, right? The wheel object. But the wheel object is for me is just a float. I think that's the problem. Okay, so the problem is that this is just a float. So we have to change the vehicle configuration. So each wheel is actually an entity itself. So public struct wheel configuration I component data. And I think each one of these needs the vehicle entity. But that would be circular. I don't think that's right. Let me take a quick look here at vehicle configuration, what they've got here. So they've got the, yeah, and then they've got the body, which is just a float. And then for the wheel, the wheel has the actual vehicle entity in it, right? So we do that. And we would remove that. And then here we would say we have the graphical representation, which would be public entity graphical or wheel mesh entity. Used for steering, used for driving. And then the chassis from suspension, which is a rigid transform. This would be public rigid. Oh, maybe that's it. Maybe these need to be rigid transforms. Let me try that. Let's try rigid transform for these, and then we'll see if that works. Right? This would be author. So how are we getting the rigid transforms? That's the question. Suspension. Huh. This is using a combination of the world from chassis and world from suspension. Is this not auto track? That's kind of the part that's kind of confusing to me. Say find usage. That one and sorry. Yeah. Get wheel info. Okay, rigid transform is position and rotation. So it's nothing special. Interesting. Rigid transform. World from suspension. I kind of understand what's going on here now. So what we're doing is we're getting the world from the suspension, the world from the chassis, and then we have to recompute that every single time to get the offset. Graphic representation, entity, transform, get child, 0, 2. Get entity wheel. Excuse me. All float 3. Yeah, a float 3 is just a vector and dot, a vector 3 and dot. But vector 3s are kind of just a point in space, and it doesn't necessarily need to get updated every time. So if we don't have the relative if we don't have the relative position of the Oh, I know how to make this change. Wait. I think I know how to make this change. I think I just figured it out. Oh, wait. Yeah, these will stay float 3s. Okay, so what we can do is we have the vehicle location, right? And then the float 3 is the relative position of the relative position of the current from the current vehicle to where we to the wheel, right? But right now I don't think it's stored that way. I don't think it's stored as a relative location. So if I can get the relative location in here, instead of doing this, what we do is we take the uh do one sec. Get position relative to the vehicle. Okay, so I think it was like what was it? It was like math dot inverse. Yeah, I think it was math dot inverse. Math dot inverse, and then you give it the world from chassis, which is the entity dot what? No. Oh, wait. Which would be that, which would be the vehicle. Wheel radius. There's the wheels themselves. Where's the chassis? Where am I getting the chassis from? Do I not have the chassis? I thought I did. Oh, I only have the chassis in here. Interesting. But is it that's not even the chassis, is it? To do vehicle parameters. Game object. There. Then we would have the vehicle chassis. But I think also if I take this entity here, Give me a sec. An update. No. Bake. Here we go. Get wheel info. Wheel transform parent. Okay, so the wheel actually should have everything. World from chassis. Okay, so if I do this and we do just be a rigid transform, and this would be world from suspension. Then we do another rigid transform, world from wheel. No, world from chassis, world from chassis. And then we do the vehicle itself. Add component entity, vehicle mechanics for baking. Vehicle mechanics for baking. It's kind of annoying that like entities don't follow each other. I want the offset, right? Is really what I want. That way we don't have to recompute it all the time. So if I like get the offset of the wheel from the chassis, right? We have the vehicle object here, so the vehicle chassis. Well, the vehicle doesn't have anything attached to it, so you can't really query for it because you can't really query for it. It's a little bit fucky. Authoring vehicle chassis dot transform dot position, and then we do a math dot inverse, and then we pass that in with the wheel. We'll say authoring dot wheel there, right? Rear left. Dot transform dot position. This should give us the location of the wheel relative to the, if I'm not mistaken. That's what this inverse does, right? It's complicated. Huh. So there are ways to do it, and that's what I'm trying to figure out. So if I take a look at this here object and I go like this, right, and I go runtime, these are all of the things that it has. It has vehicle steering, vehicle speed, right? Vehicle, demo vehicle body, vehicle camera reference, camera, vehicle config. So it has the vehicle config, right? And then if we come down here and we look at chassis, chassis has these. And here we don't have anything specific to the vehicle, right? We go to, I think it's mechanics has the wheels. So this we can't really grab this directly, right? So let's check out the suspension. Unity transform child buffer to do entity scene. So it's flagged for entity simulate. That's fine. And here, demo wheel. Here we go. So this is how they're doing it. They've got the demo wheel, which is giving the offset position here based off of chassis. That's kind of nice. But wait, where's that's the chassis from suspension. So the chassis is here relative to the suspension. But where's and then here's the wheel, like the graphical representation of the wheel itself. And this doesn't really have anything special on it. Yeah. So it's getting attached to this wheel. But if I look at this, vehicle steering, wheelbase, vehicle friction. It's the camera. I don't care about the camera right now. Is the controller not referencing the wheels? Well, yeah, so it has to have a tag that you can query for. And then each wheel needs to have enough information to construct the data required. So if we do this, right, the way they're doing it, we'd need this. And then this needs to get attached to. So these these become the tags. And then when you're doing the system, right, you query for the tags. Right? So like when I do this for each, we're saying, hey, grab anything that has the dots player, right? So anything that has this attached to it, this attached to it, this attached to it, and this attached to it, right? So is it doesn't distinguish like which one it is. It just says, hey, all of these, and I don't care about anything else. I only care about these, and we're just going to run over all of these. So these are effectively like your like an SQL query, right? So so you've got this giant list, this giant um, spreadsheet of everything in the game, right? And these are effectively like your columns, right? So you've got a row of every entity in the entire game, and these are your columns. And you can filter by column, right? So you can be like, hey, I only want to see, you know, uh, entities that have the tag dots player on them, and then it will only grab those. But then you will only have the data available through dots player. Yeah. So like if I say I only want the dot, so if I do for each and I only pass in the dots player, I will only receive back anything with dots player attached to it, and I will only have data from dots player, right? And the idea is that you're not wasting resources dealing with. So the end idea is that you're not wasting resources looking at things that are irrelevant to what you are trying to do, right? Yeah. Okay, so local, so this isn't enough information. It almost feels like the wheels have to be done. I don't know, and kind of like the part that I don't like is that it feels like the wheels need to be processed separately from the actual vehicle itself. And it's just like that doesn't feel right. Or the wheels do all the processing to keep the vehicle above, and then you push on the vehicle from the wheels, right? So like let me let me draw this out so I can be sane as well. Yeah, so we can get the idea of like what I'm thinking here. So we have our vehicle, right? Our vehicle is this nice little block, just this beautiful block, amazing block, right? And then we have the wheels, right? And the wheels are pushing up, right? And we can grab information on the individual wheels. That's cool. But then if we go and then as long as we have enough information to grab this, we should be able to push this. So if each wheel has access to the chassis, right? So if each wheel has access to this, then we should be able to push on it. And then each wheel can apply force to the bottom of it. But does each wheel need to be able to push on it? That's kind of like the weird part. Oh yeah. Yeah, yeah. That's gonna happen. So I think what they're suggesting, right? And bear with me. This seems to be what they're suggesting is that you have two systems, right? You have the wheel system, right? So you have the wheel system, and then you have the vehicle system or the chassis system. And these operate together in the fact that the wheels push so the wheels push up, right? Wheels push up and the chassis pushes forward. And then I guess yeah, something like that. I mean, from the way when I messed with ECS, the systems were separated from each other. They are entirely separated from each other. Right? That's why I'm like that's why I don't like I don't really like this system because then the wheels could update and the vehicle doesn't. Like the chassis doesn't. And it feels weird, but like it might be the way that you're supposed to do it and I don't like it, but I don't have a better way. I almost want to see if I can like part of me wants to be like, "Hey, can I produce enough AI without dots to skip dots?" Cuz vehicle inside of dots is kind of shit. Doing a vehicle inside of dots is proving to be a little bit shit. The other thing that I could do, right? And this could theoretically work as well, is if the I don't like the idea of that because like if I have the wheels, each wheel updates, then each wheel would also potentially update the forward. And I don't know if I like that. What I ideally want is I want the chassis and then I want each wheel and then we can just bounce off the wheels. That's what I'm trying to do. I'm trying to avoid having a separate entity for the wheels that we then have to query for and run in a separate system. That's like ideally what I'm trying to do. So wait, if I do okay, so we have the vehicle configuration, not vehicle controller. Vehicle configuration dot value read only dot parent vehicle entity. That's not quite what I wanted. I wanted what was it? It was a wheel. Not vehicle controller. Can you please stop that? Vehicle authoring here. Suspension. That's what it was. It was suspension. Suspension point forward left, right? Can we do a dot parent on that? No, because it's not an entity. It's a point. If it's an entity, then we can. If it's an entity, we can query it for more information. Authoring dot wheel. Okay, so turn game objects into entities. How did we do this? It was in here, right? Yep, that was it. There we go. Front left. Rear right. Rear left. I kind of want that to be. No, wait. There we go. Now we can get rid of this. Then if we come back to here, dot parent dot. What does this give us? Okay, so then if I go like this and we come in and then we build, right? Yeah, suspension dot transform POS. Okay, so what we're going to do is we're going to take this and we're going to comment this out for now. Then we're going to build, and it's not going to fail this time. We have a lot of warnings there, though. Oh, those are the extensions. That's fine. Okay, so now if I do, oops, if I do this and then we do a debug, I should be able to hit play and see what these values are. Like see what I have access to. That's what we're looking for. There. And then if I come into here and I hit play, we should pause right here at some point. The associated modules were unloaded. What? Here's our velocity. This is what I'm curious about. This has a position, the local transform, right? But I don't know that I have a way of accessing the local transform. Get rigid body index? And we're passing in the entity index. Oh. So if I have world dot get rigid body, get position. Oh. Oh shit. So if we do that and we pass in the wheel, right? Vehicle can vehicle configuration dot value read only dot suspension front left, right? This is the int point index, right? Then we can get the if I spell suspension right, that would be nice. I don't think I spelled it right there. Give me like 2 seconds here. Did I spell it right? I feel like I spelt it wrong. I didn't. I spelled it right. Okay, so suspension point index, right? Then we can get the suspension point front left, suspension point front right, int suspension point rear right. There we go. Okay, so we have those, but then we can also get the rigid body position, right? Oh no, they don't. Fuck. You're right. God damn it. Dot value read only dot point front left dot. There's the index. Huh. To do Unity ECCS get entity get transform from entity.
Hello everybody and welcome to today's video where we're going to be talking all about transforms in Unity's entity component system. Now this is a very important topic because of course this relates to how things are positioned and oriented and scaled within our game world.
There is get component data from entity. Get component data from entity. Ah, that's probably it. Get component get. Would that be on the vehicle config object itself? Dot get component. Get component data from entity. Oh, we shouldn't use it. Yeah. Get component lookup instead. And this is part of the I component data struct implementation. So it should be this dot get component lookup. What was it? It was get component lookup. How does this get used? It's part of the implementation of get component struct here. Wait, did it? No, this is the new one. Unless I'm on the wrong version. Yeah. Component system base. Oh, this requires a component system base, and then we use get component data from entity off of it's a method of component system base. System implementation should inherit system base, which is a subclass of component system base. So I think that's the state maybe? Uh, yeah, it's gonna be fun. Dynamic shared component. Order version. This gives us back a. Sorry, not that one. Where was I? Entity manager. That's what I was looking at. Which is system state, and then the entity manager gives us back a entity manager. Entity manager inherits from an iterable entity manager. What? How can it inherit from itself? There has to be a different one. Unity ECS get transform from entity. Entities component. Local to world, local transform. You can use Unity transform namespace to control the position, rotation, and scale of an entity in your project. The following components are used in the transform system. Local to world, local to transform, post transform matrix, parent child. There are two systems that update their transform systems, parent system and local to world system. Transform hierarchy. Unity transforms is hierarchical. This means that you can transform entities based on their relationship to each other. For example, a car body can be the parent of its wheels. The wheels are children of the car body. When the body moves, the wheel moves with it. You can also move and rotate the wheels relative to the car body. An entity can have multiple children, but only one parent. Children can have their own children entities. These multi-level parent-child relationships can form a transform hierarchy. The entity at the top of the hierarchy without a parent is the root. That makes sense. To declare the transform hierarchy, you must do the following. You must do this from the bottom up. This means that you use parent to declare an entity's parent rather than declare its child. To declare a transform hierarchy, you must do this from the bottom up. This means that you use parent to declare the entity's parent rather than declare its children. If you want to declare a child of an entity, find the entities that you want to be children and set their parents to the target entity. For more information, see the using hierarchy documentation. The local to world matrix represents the transform from local space to world space. This matrix is what the renderer system uses to render the entity's geometry. By default, the local to world system updates this updates this component from the local to world component. This default update means that you don't need to update local to world, and the system does that for you. To disable the automatic updates, use a right group type of local to world attribute on the component with the right group. With this right group, you have complete control over the local to world. More information too. The local transform component has three properties. They control the position, rotation, and scale of the entity. When this component is present, it controls local to world. The local transform component has three properties. They control the position, rotation, and scale of the entity. When this component is present, it controls local to world. If the entity has a parent component, position, rotation, and scale, if the entity has a parent component, position, rotation, and scale are relative to that parent. If the entity doesn't have a parent component, the transform is relative to the origin of the world. The post transform matrix component. Okay. So I think I kind of get it. It has to do with authoring. This won't work. They don't have rigid bodies. State manager, we're going to get rid of that. Okay, so get entity here, right? But we need to do more stuff on this, right? So if we pass in the authoring wheel, so if we do like void get wheel entity, and this passes back an entity, then we pass in the vehicle authoring. We're going to call it authoring again. And then we pass in the parent entity. So this is going to be an entity. And then we're going to say parent entity. Then we do this. And this is an entity. Wheel entity. Oops. T equals what's the issue here? Did I spell entity wrong or something? No, we can't. Okay. Then we do. Apparently, we can't use that here, so we'll do. Then we'll do we'll do another entity. We'll pass in, and this will be the child entity. There. So this will pass in the entities themselves. So we'll do the child entity dot parent. Nope. How do we assign the parent though? I think that's gonna come back to this wheel info thing. I don't like native array. Wheel baking info. Rigid transform. Oh, you know what? If we give it a rigid transform, that might count as a rigid body, and that might be what they're doing. Because they're giving a rigid transform to it, and that might be what's giving us the parent-child thing, right? These being temp is kind of wrong. I was looking into this yesterday, and temp doesn't seem correct. This is the world from chassis and all of that. And then this comes back with a wheel baking info. And wheel baking info is kind of what we need, I think. Yeah, we need that. Wheel baking info. I think so. Constructs a rigid transform from a rotation represented by a float 3 matrix and a translation represented by a float 3 vector. A rigid transform represents the identity transform. The translation part of the rigid transform, the rotation part of the rigid transform. And then we can do other methods on top of it. Yeah, it doesn't quite sound like a rigid body. Vehicle design approach. I think no matter how many vehicles you have in your scene and no matter how you implement them, it's likely that the overwhelming majority of the frame cost of your vehicle will just be the physics simulation slash queries either way. For that reason, I'd suggest picking whatever approach is easiest for you to do. Okay. It's hard to imagine a game still running smooth with more than 500 active vehicles in the scene. And even at that count, I don't think memory access patterns will make a huge difference, especially if getting better memory access patterns means you have to schedule more jobs or make them structural changes. I actually plan on putting my cars like so there'll be the player vehicle, and then the rest of it will just be like vehicles on tracks. Sorry, it was just a tiny bit chilly. Option A vehicle is an entity with vehicle components and dynamic buffer. There's one single vehicle update job. The vehicle update job goes through each wheel in the wheel entity buffer. And for each one, get the wheel component on it and process the wheel update. Be almost the same as option one, except wheel data is stored directly in the dynamic buffer of the vehicle instead of in wheel components on the wheel entity. A vehicle is an entity with vehicle component and dynamic buffer. First, a early vehicle update job iterates on the entities that have vehicle components for each vehicle. It goes through each wheel entity of that vehicle, gets the wheel component on them, and sets data in them to tell them how to move. So I feel like A is what I want. So dynamic buffer. Hard to tell which one of these will perform best. At a low vehicle/wheel count, I'd go with option A or B. But the problem is that I'm not sure what a low vehicle count would be. We'd have to profile and see. That's true. It could be 50 or 5,000 because of the cost of the physics update compared to the cost of the vehicle logic update. It's possible that the vehicle/wheel count threshold at which option C starts to perform better than A or B. Hmm. What? What? I thought I was signed in. Yeah, got it, got it, got it. Boom. Okay, we're signed in. These two here are what we want. So let's bring them into the project and take a look at them. We're going to create a directory, scratch tests. And then we're going to dump these two in here. Then we're going to rename these. Oops. And then I'll rename this one. And then we're going to open both of them. And we're going to see that we have an I component data with the wheel friction, wheel rotation, wheel dampening, wheel suspension distance. These make sense. Collision entity. Interesting. I buffer data. Wait, was I missing that in something here? No, I was not. Okay. Collision entity. End frame physics system. That must be new. Or sorry, this must be old. When was this presented? 3 years ago. Okay. So some of this is going to be old. That's fine. This is the system base, which is just an I system. And add hit. Wheel collector. Entities. Here we go. In rotation. So the entity here, what kind of entity is this? Vehicle, component, entity. Vehicle up, which is the rotation value. That actually makes sense. We'd want that rotation value. Where's rotation value coming from? Oh, it's just rotation.value. Okay. Huh. All right, so what we're going to do is we're going to do this. We're going to come over to here because this is largely broken. There. But I like this, that we've got some ideas here. What I want to do, I think, why is this causing a problem now? Oh, that's why. The wrong one. I meant to do this one. There we go. Okay, so we can get rid of this. We're gonna test something real quick here. So if I do a float 3 on all of these again, right? Float 3 position. Right. And then we come down here and we do the we'll just say wheel. Wait, these were the, oh, these were game objects. That's not what I wanted. There we go. So if we say equals authoring dot wheel front left dot transform dot position, right? We do this for all of them, right? So wheel front right authoring to do. There we go. There we go. Then if I come back into here after I build, we stop. Stop and build. We come back into here. We come back into here. All right, we click on this, we hit save, right? This gives us the entire list of everything, right? So here these are not the world positions. right? I don't think these are world positions. Yeah, they're not local transform. They're the local to world, and I want the local transform. Transform dot local position. That's what I want. So now I have the local position. The local position is just the offset, right? So we know the exact point at which we want the the suspension to be, right? So then if I come back to here, I'm just going to close this one. We don't need to keep this open. Don't save. I don't care about it. There we go. Okay, so now we have the position, right? So I'm going to click on this and we're going to take a look at the computed stuff. Right? So we have the local transform, which is the position. We have the world local to world, right? That's fine. Dot simulation here. We have this rigid body, and we have the local transform here. Now what I want to do is I want to say, can we actually build a struct and attach it? Yeah, because everything's relative to the chassis. So now all we need to do is turn local wheel transform into world transform. That transform based on chassis. Based on local transform. Wait, what is local transform? One sec. What is local transform currently at? I want the world transform, right? There's our local transform. Local to world is what I want. So if I do yeah, I would want the world for so if we do ref read only uh world transform, or is it local to world? Local to world. Then we do the same down here. Is this one too many? Then we do this, and we do a ref read only local to world. Where's this? Where's that one? Where's this one? Oh, I see it now. This comes down like that. There we go. There we go. And now we have the local to world. So now we can get the offset for this. Oh, this is gonna be so jank. Where's my queries? Here's my queries. That's the steer. Here we go. Debug extension there. And what we're gonna do is we're gonna take the race start at suspension front left wheel front left position plus local to world dot only value dot position. I feel like that's right. And then local trends to do this needs to be minus. Okay, and then I'm just going to build. And then if I hit play, we'll see if it worked. It worked. I don't know if it's in the right spot though. It's kind of hard to tell because like if I come into here, I don't see it. Is there any way to like just pop this into essentially a scene controller? So I'll show you what I mean. Right? So like usually with when you're not doing dots, you can just toggle back to scene and you've got this free camera, right? Effectively, I want to be able to do scene but within the game instance here. I wonder if the answer is just to like actually do something on the camera itself, like have a temporary controller, like a bog standard just basic controller that's not physics based, and just go from there. Unity basic flying cam controller. Camera controller to easily fly around the scene. I think this is like literally what I'm looking for. No, I don't know if it's a bug on my side or if it's just the way it is. Because like the scene's not the scene, right? The scene is contained into a self. Oh, you can see that though. Oh, that's dope. So I can't see the the thing, but I can see the draw. Yeah. So it's right there, but I think that we're which wheel are we trying to do right now? We're doing the front left wheel. That is not the front left wheel. Based off of this is not the front left wheel. It should be right there, and it's not. So our math is wrong for what we are looking for. It's in the wrong spot. So I think this just does what we want. So what we'll do is we'll come here and we'll do controllers and we'll add a new Unity script, fauna behavior. Flying camera. Flying test camera. Yeah, and then we'll just paste it all into here. And then we do that and come up to here. Oh, I didn't even know this was an option. Yeah. That's kind of cool. There, and we'll build. Interesting. Oh, so this would be like truckin'? Whatever. Build. I'll worry about namespaces later. I do want to do some namespacing. So I can clean things up and have them like, yeah, just clean things up. It's going to be important down the line. Okay, so then if we go to the main camera and we go to the flying test camera, we drop that in there and then we hit play. Does it just work? Yes, it does. Sweet. So that's definitely not in the right spot. But that worked. That was like exactly what I wanted. Look sensitivity, I think 0.75 is probably what I want. Okay, so convert. Okay, so what we want to do is convert local position to world position unity. So slow transition to typing, no worries. Transforms position from local space to world space. Note that the returned position is effectively a scale. Use transform direction if you are dealing with direction vectors. You can perform the opposite conversion from world to local space using transform inverse inverse transform point. If you need to transform many points at once, use transform points instead, as it's much faster. Some object, the position. Given 2 points, create an offset. Wait. Given a world position and a offset point. Get the world position of the offset point. To calculate the world position of an offset point, as given a base world position, add the offset point vector to the base world position vector in 3D space, is effectively translates the offset point to the same coordinate system as the world position. So why am I getting a weird spot? That's what I thought would be the answer, and that's what I did. Local to world position. What is local to world position? Okay, so let's draw here a we're gonna draw this blue one here, and it's gonna be blue, and this is gonna be the local to world position. Blue. Let's have a radius of 1 and a duration of 10. And let's have let's increase the duration to 10 here too. And then we can build. Did you take off work again? And Don, I got laid off. I got laid off, so I'm looking for work at the moment. It's just only so much you can do. Yeah, shit happens. Shit happens, oh well. I got severance, so I got a little bit of time, and EI is coming, so I just gotta keep looking. Hopefully I'll find something. I've had a couple interviews so far, so. Okay, so the world position's correct. You'll bounce back. Yeah, hopefully. We'll see. I'm sure that it won't it probably won't be too long before I get something, right? So I've got probably I think we get 10 months of EI. So I've got about 10 months to find something. You know, what is it? How long is EI in Canada? $45 weeks. Yeah, 10 months, give or take. So I'm going to take the time to look for work and focus on growing my online presence. And it was like, well, I might as well, right? Because we don't know how long it's going to take, but hopefully it doesn't take too long. Okay, so my offsets are not right. Yeah. Thank you. I also thought it was a good idea. Okay, so our start ray position is wrong, right? There's the math dot inverse, but I don't think that's right. This what's this do? Fast. Okay, wait. Fast matrix inverse for rigid transform based on translations. That's not really what we're looking for. I'm trying to figure out why my positions are off. So my world position is correct. But my vehicle position is wrong. Local transform dot inverse. Rotate, translate. What's this translate do? Translates this transform by a specified value, specified vector. No, this does not modify the original transform. Rather, it returns a new one. Scale this transform by a specified factor. This returns back a local transform? Wait, does world transform have that then? Local to world dot. Now you read only dot. The entity's position in world space. Yeah. It sucks a bit though. The up vector in the entity world space. The right vector in entity world space. Okay, so this is that dot not transform? Transform point. Maybe? No. This is supposed to work. Why is this not working? Oh, right. We need the center of mass, right? It's probably the center. I think I know exactly what it needs to be. We need a center of mass. Center of mass. Game object. No, this is transform. Transform. Center of mass. There. And then here. I don't think we're actually using that. Oh, we are. Wait. Wait, this wasn't causing problems anymore? Oh, this is the physics stuff. That's why. I gotta close that. I wanted my stuff. Vehicle configuration here. Yeah, this is what we wanted. Vehicle permit, vehicle chassis, public game object, center of mass. And then we come up to here and we do public rigid transform. Center of mass. Actually, no, because that's still going to give me the wrong thing, isn't it? What if I do a rigid transform? Right? Like what if I actually just do this? For all of these? And then we've got a little bit more data. Yeah, it's going to be a little bit bigger, but it's a little bit more data. And then we can probably do this. And then this would be new rigid transform. Then we pass in the local position and dot rotation. Author. Sorry. Do the same thing here. Transform here. Then we do that. Transform dot. Can we just do this? Oops. Yeah, it just takes a flip 4 transform, which I think this is, right? Oops. No. Wrong thing. We just want this one? Is this wrong? Why is this wrong? Argument transform is not assignable to float 4 transform. Transform dot position. And then we want authoring dot wheel front left dot transform dot rotation. Oh, it takes a quaternion first. There we go. Local rotation. And I want local position. And this is rotation. There we go. Wait, what? Oh. Do. Get rid of that. Don't actually care about that. This we care about down here. So this would be local to world dot value ro dot. So if I do vehicle configuration dot value read o dot position dot convert to. Nope, not that one. Dot POS. What does this give me? The translation part of rigid transform. Turnian. Float. Constructs a rigid transform from a rotation. Let's see. Represented by a unit of quaternion and rigid transform. So if I have a wait. This returns a transform, right? Sorry. If I come back here and we do the one sec. Local to world dot value read only dot transform, right? This is a transform, right? This is a full transform. Local to world is a transform, I believe. Local to world. Local to world. Is the value up, position, rotation. We've got position and rotation, right? So what we want to do is calculate the ray start position based on the local to world transform form with the wheel position transform. Did it? So we have this one. Returns the transform equivalent to the floating. Returns the transform equivalent of a float 4-4 matrix. Throws an exception if the matrix contains many form scale shear or shear. No, I don't think so. Where am I getting this quaternion from? Oh, wait, no, never mind. Ignore me. Yeah, no, this is pretty simple. I don't know. Okay, so like the big issue that I'm running into is that like we've got this weirdness between these two. Because like this should give us the exact location on like the correct location for the front left position, right? So if we build this, this should give us the front left position. But the start is not the correct one here, right? So if I come back here and I hit play, right? The sphere is being spawned in the wrong spot. It's the rear. Oh, it's being spawned at the rear. Why is it being spawned at the rear? Yeah, why is it being spawned at the rear? We're giving it we're giving it the front right position. So maybe we've got the wrong position in here. Vehicle configuration. Did we give it the wrong position here? Front right, front left. Okay. If I come into here and I go down to here, we do authoring. We come to this vehicle chassis. Just do this. And then the center of mass. For now, we'll just say it's the vehicle chassis. It's fine. There. Yeah, these are all correct, but they're not coming through correct in the when I'm actually doing the calculation. So it's off when I do this. Sorry, this. So let's do a debug. Debug.log. Actually, we can just draw the wheel, right? So let's do this. We do green? No. Yellow? No. Mm, we'll do blue. Uh, and we'll drop that one for now, and we'll just do this. Oh wait, no. We don't want to draw a thing because if we draw it, then it will be drawn in the wrong location anyways. What we want is we want to debug.log. Debug.log, and then we'll do wheel, front left, position, there. That's cool. That's not what I wanted, but this is fine. Front left, because we're only doing it on the front left. Yeah, okay, there we go. So then if I come back to here, we should see it being logged at the very least, right? So we clear, we hit play. Okay, there we go. And then we go front left suspension is correct. So why is it not doing the thing? World position? Do world, wheel, front left, world position. And here we're going to do the chassis world position. Chassis position. Yeah. Then we can see what our calculation is giving us, and it's giving us the wrong data. I have a feeling that this might be the wrong number, and that's what the problem is. Okay. Clear. Clear. Man, Unity is a freaking slow system. Okay, so if I go player controller, we look at position. This is a little bit different. Not like a lot different, but just a little bit. Switch. Oh, yeah. Runtime. There we go. Oh, I see how this is working, I think. So we've got the local to world. And then this is the position itself. Oh. I think I get it. So we actually want just local transform dot position, value read write dot position. I think that might be what we want. As weird as it sounds, I think this is what we want. Like local transform just doesn't seem right. But because there's no parent to it, it kind of is right. Because its local transform is relative to the world. I really need to get around to fixing that green screen. Yeah, that's what we're getting for there and for here. So local to world actually has everything, I think. Where are these coming from? Like what are these relative to? Can I change these? Probably not what we wanted. Why are these so wrong? This is should be right. Why is this going? Why is this higher? That's interesting. The Y is definitely off, but not in like a hugely meaningful way. It is. Everything is just kind of a snapshot here. But like the thing that I'm trying to figure out is so this value here is correct. Like if I change this, we can see this moving, right? But this transform here is not in the right spot, even though it's supposed to be, right? So like if I take oops, if I take can we stop? There we go. Okay, so if I take this is supposed to be the front left wheel. If I move this, right? It's supposed to be the Z axis is wrong. So it's oh. I think I know. I think I know what's going on. Okay, I just figured it out. The math is wrong. No, so like okay, so if we do new, I can explain, right? So we have the wheel, we have the truck, right? We have a wheel here. We have a center of mass here. Center of mass is pointing this way, right? The wheel itself is relative to this. So what's happening is if I take a look here, right? So the front wheel, this wheel here, or wait, no, this wheel here is showing up right around here because the truck's forward, like it's relative, yes, but like it's this is relative to the forward vector of the truck, and that's not being taken into account in this calculation. Yeah. So we need to do this times the local world local transform dot uh, maybe local to world dot value ro dot forward, and this might fix the problem. Hmm. Let's see if that works. I think it did. Oh, look, it worked. Uh, private static void. Um, Interesting that up is a function and oh wait. If I just do local to world, and then we just do up. There we go. Better. Okay, so all we have to do now is do this, right? For all of them. So we just do this. So you just so you know, like actually doing it this way ends up actually being faster. Yeah, and then all we have to do here is change this here. Front right. There we go. This would be rear left. Rear right. Do. There we go. Now we have all of them winning. Inlining stuff, it makes it faster. Just FYI. But it's a trade-off depending on how much memory you have because it also makes things it makes your code bigger, right? Like the actual code required is bigger, but you get a speed performance. It's a trade-off between physical size of the code and speed of the code. Although like we're not talking about like massive amounts. Just as a like it would probably benefit me to not do it the way that I'm doing it right now, but for now this works and that's the important thing. Do huh. I don't think we're getting all of our points. Our points are wrong. These points are horribly wrong. Calculate offset position of a vector based on the world position given position and rotation. Vector 3 Give me 1 sec. I'll be right back. Okay, I think I'm almost there. Target rotation. I get back and we're in an ad. Sweet. High offset. Uh, Rigid transform. Now, what is the transform type? Its position. What's the type on transform here? Okay, let's see here. Position, rotation. Here's the transform matrix. So maybe a float 4x4. Yeah, there's so much stuff that needs to be removed here. We're just gonna do some quick pruning here. Chat GPT. Do you know Unity ECS Unity dots? Okay, cool. Given a this here is a rigid transform. Given a rigid oops, rigid given a position offset and a world position transform, and the world position transform data, can you figure out the world position and of the offset with the there. I bet it gets it wrong. Please take into account the current rotation of the of rotation of the parent. That actually might work. Turn in. Parent rotation. Parent position. There. And then we do when we delete this. Don't need that. Then we take this. Can we do that though? parent rotation. Then the offset. This would be a float 3. Offset. Offset. Position. And then parent world position. And then this would be a return. And I'm guessing that these can't actually be multiplied. The operation quaternion and float 3 candidates. Yeah, that's what I thought. I think it's this one. Identity. Construct a unit quaternion. Axis align. Returns the quaternion representation representing a quaternion representing a rotation around a unit axis by an angle of radian. Yeah, it doesn't look like you can do it with the lowercase ones. Returns a quaternion constructed by first performing a rotation around the x-axis, then the y-axis, and finally the z-axis. No, I knew what you meant. Yeah, because this is complaining that cannot apply operand multiply to operand of type quaternion and float. We could try flipping them. But we're probably going to, yeah, we're still getting the same one. So we need to, you know what? If we have this and we do value, I think value returns a float. Oh no, it returns a float 4. What if we flip these then? I have a feeling that it's not the case, but it was worth a shot. Ooh. What a world forward. You would think that this would be it, right? There's the forward vector. Oh, but we don't have the right. What if we multiply or add the local to world dot value read only dot right? Like, what if I do this? No, I'm in the same boat. What's the error here? Oh, there we go. Build. That's not quite what I want. Turnian dot apply. Oh, you know what? I think I can do this. Oh, this might be it. Local to world dot value dot rotation dot apply, or sorry, dot hmm, Euler XYZ. And then we do vehicle configuration dot value read only dot wheel rotate wheel position dot pos. Damn. That's not right. It's a float 3, so what's the error? Cannot associate static method. Oh. Wait. This is supposed to be static. What is this? Is to do Unity mathematics quaternions. Rotate X. Okay, so what if I do rotate X? No, that's not it. Forward and up. Mhm. Maybe it's under math. Okay, so if I come back into here and we do math dot, what does this do? So we pass in a quaternion and it pops out a float. Okay, so if I do this, local transform. Give me a second here. And we do rotation. This would pop out theoretically. I feel like this would pop out the correct rotation for this. I'm probably wrong. Definitely a little bit wrong. Okay, so yeah, okay. What we need to do is take this and do all of this on only this one up here, because this is the most important one right here. This way we can visualize just one of them. Was this working? Oh, oops, my bad. All right, let's see how off we are. Okay, so what we're gonna do. Okay, so this has. Yeah, this is not the right spot because it's supposed to be right here, and it's not. So local to world. Then I don't care too much about this so much as I just want this in the start position for now. There we go. All right. We clear, we hit play. We should see the start position. Hopefully. Where's our start position? Yeah, our start position's wrong. Because it should be right here. And it's not. It's down more. It's down too much. So this is wrong. Given a quaternion, and a position with and an offset, how would I find the world position of the offset? Unity dots. Rotation. This dot transform rotation times quat offset. Streamer mode activate. Okay.
Hello everybody and welcome to today's video where we're going to be talking all about transforms in Unity's entity component system. Now this is a very important topic because of course this relates to how things are positioned and oriented and scaled within our game world. So we're going to be doing this with pretty much everything that we can visually see within our game. Now I want to talk about this because the way transforms work in standard Unity game development is quite easy and pretty intuitive and you can pick up on it pretty easily. Now with Unity's entity component system things are a little bit more complicated and if you kind of go to the documentation to learn a little bit more about it, you might get kind of overwhelmed. They have all these diagrams and all these acronyms that they're using and everything like that. So it can be a little bit overwhelming, but I promise it really is not all that complicated. So today I kind of just wanted to go over how transforms work in Unity's entity component system, and then after that I'll be showing you how to actually work with these transform components so we can do some cool things like the sample project that you see playing behind me, where we have these fighters moving around and rotating and doing all sorts of things in relation to the stage, while the stage is flying through space, very similar to Final Destination from Super Smash Bros. So anyways, before we get into all that, I'd just like to say if you do find today's video helpful, I'd really appreciate it if you hit that like button. Also feel free to subscribe to the channel for lots more videos about Unity's data-oriented technology stack and their entity component system. Of course, if you do have any questions for me or suggestions for future videos, feel free to leave those down in the comment section below or join us over on Discord over at tmg.dev/discord. Alright, so for starters, I just want to briefly touch on how transforms work in traditional Unity programming. So if you're familiar with Unity, you of course know that every single game object in our game has a transform component. Even if it's just some whatever manager script, it still has to have a transform component on it, even though it doesn't necessarily need to physically exist in our world. Now the entity component system is a little bit different because entities actually don't have to have any components on them at all. They can be completely empty. And in fact, if we want, we can just store just regular raw data on it. We don't necessarily need any transform data if this entity doesn't necessarily need to live anywhere in our world. So that's kind of the first thing to keep in mind with Unity's entity component system is that not every single entity is going to have the transform components that basically allow it to live somewhere in our world. Now, if we do want it to live somewhere in our world, the end-all be-all component of where this entity physically exists in our world is called the local to world component, and it is a float 4x4 matrix. So it's basically a matrix of 4x4 of all float values, so a total of 16 float values to calculate where this entity actually exists in our world. Now, this local to world float 4x4 matrix, basically using that, we can calculate the position, rotation, and scale of the entity just using those values. Now, it is possible to directly modify the local to world component, and I wish to be showing you how to do that when we get to the tutorial section of the video. However, to make it a little bit easier, Unity has provided us with a few different components that we can actually modify more directly that will calculate the local to world value. So these are the translation, rotation, and scale components. Now, there's actually two scale components, and we'll be talking about that in a second. But the translation component basically is where it exists as a position in the world, and that's a float 3 component, and that's basically the equivalent of a vector 3 transform.position like we see in regular Unity. The rotation component is a little bit interesting because it's of type quaternion with a lowercase q, so it's different than the capital Q quaternion type in regular Unity. Now, really the easiest way to assign all the necessary components to a particular entity is just by using the conversion workflow. So this is basically where we have a game object set up in our scene, and then we attach the convert to entity script on it. Now, when we do that and we run our game, it's going to basically convert the transform component into the local to world component, the translation component, as well as the rotation component. Now,
That's what why we stopped watching this before. Unity dots. Convert to entity.
Now, if the scale value is set to 111, so that's just regular normal scale, then a scale component is not added to the entity at all. However, if the scale is anything but 111, then it's going to add a non-uniform scale component. Even if we have values of like 333 and it is technically like a uniform scale up, it's still going to add a non-uniform scale. That's just kind of how the conversion process works right now. However, like I did mention, there are two scale component. Now, if the scale value is set to 111, so that's just regular normal scale, then a scale component is not added to the entity at all. However, if the scale is anything but 111, then it's going to add a non-uniform scale component. Even if we have values of like 333 and it is technically like a uniform scale up, it's still going to add a non-uniform scale. That's just kind of how the conversion process works right now. However, like I did mention, there are two scale components. So there's the non-uniform scale component, which I just mentioned, and there's also one just called scale. And this one just takes in a float value. And so this is basically for a uniform scale. Now, if we want to use this uniform scale component, we actually have to manually add this through code, and I'll be showing you how to do it. It's basically just as easy as adding any standard component to an entity. So anyways, using these translation, rotation, and scale components, from that, we can basically calculate the local to world component. And again, this is kind of the end all be all of where the component exists in our world. Now, things start to get a little bit more complicated when we want to introduce parenting of transforms within our project. Now, parenting is useful for doing something like I have in a sample project where we have a platform that's kind of floating through space, and we want some things to move around on that platform in relation to the platform. So the way this is actually going to work is basically all the kind of fighter objects that I have, they're going to be essentially child objects of the parent, and the parent being the actual battle stage that's flying through space. So the way that this works is we first calculate the local to world of the parent entity. So in this case, the battle stage, we'll factor in any modifications to translation, rotation, and scale components to get that final local to world components of the parent. Then we can move along to the child. Now, the child is set up a little bit unique because now it actually has what's known as a local to parent component. And this is basically very similar to the local to world component in that it is a float 4x4 matrix. However, instead of telling about where this object is and how it's oriented in relation to our game world, it's giving us this information in relation to the parent object. And so with child entities, now when we modify our translation, rotation, and scale components, they're actually going to be modifying the local to parent component. So if we say want to move the translation component to the left 2 units, then it's actually going to be modifying the local to parent component. So the offset from the parent's origin position is going to be now 2 more units to the left. Then once we have the local to parent component calculated, we can now take the local to world component from the parent and the local to parent component of the child and combine those two to calculate the local to world of the child. Again, like I said, the local to world is basically the end all be all of where any object exists in our game world. Anyways, I think that's enough of the kind of theory section, and I can actually show you how this all looks inside the Unity editor now. And by the way, I'll be and combine those two to calculate the local to world of the child. Again, like I said, the local to world is basically the end all be all of where any object exists in our game world. Anyways, I think that's enough of the kind of theory section, and I can actually show you how this all looks inside the Unity editor now. And by the way, all the project files and code featured in today's video are available using the links in the description below. All right, so here we are over in Unity. You'll see that I have a Cinemachine track set up, and this is basically how we can kind of define where we want these battle stage to fly around throughout our world. And I actually use this just a regular game object with the Cinemachine dolly cart to actually follow along this path. And then there's this battle stage follower, which is converted to an entity, and this basically just mirrors the position of the track follower here. So that's just kind of like a little bit of a workaround that we have to do, again, working between traditional Unity and some of the ECS stuff here. And I see that as a child of the battle stage follower, I have the actual battle stage. The reason I do this is just basically so I can do a little bit of a rotation offset, so it is kind of oriented towards the camera how I want it to. You'll notice that on this child object, I do not have the convert to entity script on there, and that's basically just the way the game object conversion system works, is when we have parent-child relationships within our hierarchy here, and just the top level one is being converted to an entity, then everything below it is going to be converted to an entity as well, and it will set up all the parent-child relationships as we want them. So to show you how this is set up in code, you'll see that I have a battle stage managed data component. So this managed data component uses a public class rather than a public struct. Go check out the video that I did on using UI and Unity ECS to learn a little bit more about managed data components. But basically, we need to make it a managed data component if we want to reference to the transform of the track follower. And you see that this is where we're actually going ahead and moving the stage. So you see in our onUpdate function,
Maybe that's what we need. Mhm. Mhm.
we're getting a reference to the local to world, and then we're just going to be reading from the battle stage to manage data right here. So you see that we'll go ahead and create a new position and rotation variable, and we're just getting these literally from the position and rotation of the regular Unity transform on that track follower game object. And then when we set our local to world, we just do local to world.value. We'll set this equal to a new float 4x4, and one of the constructors for the float 4x4, we can just pass in a rotation and position, and then we'll calculate this 4x4 matrix. So you see if we come over here and enter play mode, and I select this battle stage follower, you see that this local to world is being updated consistently every single frame. Now you'll notice the rotation and translation are not actually updating right now, and that's because we're literally just not updating those components. We're just updating the local to world component, and that's really all that matters for getting this to move around within our world. Again, these rotation and translation components are kind of just helpers. Now if we select our actual battle stage, you'll see that there are a number of more components on here. So for starters, you'll see that at the top we have a parent. So this is actually the parent entity. Again, this is the child of the battle stage follower. So we just always have that basically as a component that we can look at if necessary. You'll notice that the local to parent is not changing at all, and that's because we're not moving in relation to the parent at all. We're basically having the exact same position and rotation, and we're not changing that at all. So the local to parent is not changing at all. Now you notice that the local to world is still changing. That's of course because we're flying through space. And then just real quick, I can kind of show you what things look like when we start to add some of these fighters in. So basically, I've created a number of these kind of data components for the different types of movement we want to have. Most of the times they're just going to have a magnitude and frequency. However, for the movement data, we also have the origin position as well. Now if we're to look at say the movement system, you'll see that we're basically just kind of calculating a new position just using a new float 3 here. We're calculating this using some sines and cosines. So then you'll see that I'm just setting that directly to the translation.value component here. So now if we look in the inspector on that fighter 1 entity, you'll see that the translation value is being updated every single frame, just like we were doing right through code. You'll notice that the local to parent is now being updated every single frame as well. And that's because we're actually now moving around this entity in space in relation to the parent. And then of course, because it is moving around within our world, not only on the stage, but with the stage moving around, the local to world is going to continue to update every single frame. Very similar with rotation, we can just set rotation.value here, and then I'm using the quaternion.euler function to
What the fuck is he doing here? Battle stage management. Movement data. Move, rotate data. Battle stage management data dot track follow position. So what's the issue here? Is this an issue? This is an issue. The type entity. Type entity must be valid unmanaged type. If I'm not mistaken, this is just like transform is. Can I do this? One sec. One sec. Unity dots transform. This doesn't make too much sense to me yet. So we build this and then we attach it. We can't use transform. So this is bad now. Because if I do this, it will stop complaining, right? Is what already a component? I don't know. Probably just do this so we still have them if we need them. We don't have to rewrite them. These are the problem here, but we don't have a, I don't think there's a, yeah, there's no, so what is a transform? Unity transform. What does a transform look like? That is the real question. What does a transform actually look like in memory? Can I convert a transform to a float 4, or does it need to be a float 4 by 4? Convert trans convert unity transform into dots transform. Unity dots locations. Advanced player controller, don't care, don't care, don't care.
Unity Dots, or data-oriented technology stack, is a different way of coding your or C# but with all of these pieces still not state out them also even graphic to expose state a whole dot string and hierarchy right that will be inside it will be component. So what we need to do instead is use the type entity. And if you would want to add a vector tree for the spawn position, we need to add using mathematics. So we can define the variable just like that, and now we'll get to Unity, where subscene this script is not a system and not even a component. Put entity into the set the prefab and the spawn rate based on the values before we run the game. This will create. So I'm adding a component. Time we have the cube spawn component. Now if we would run the game in this, because I will be using just one cube spawner in the entire scene, we can use create a new component the same way that we have done it before. That will add to all, checking if they have the cube component. If they have it, I'm also getting the local transform.
Unity C ECS using transforms. This one's useless. Setting the world position on a child entity using get go global offset API. So we need the local to world component. Hmm. Is that actually it? Hmm. Do. I gotta say, everybody's doing a really piss poor job of explaining what you need to do. Unity, ECS, attach, get local to world on child. I'm gonna set child entity position to a local to world. Desired position minus parents local to world. That doesn't work. That might work. Minus. That doesn't work because we're taking two local. I don't have two world positions. Okay, this is useless. To do. Verify that both child entities are being baked with transform usage flag dynamic. I suspect only one of them is. It doesn't work because you can't really do it without throwing a bunch of errors and memory leaks. World transform doesn't change on child entity. Was hoping that this would work, but like it doesn't because I don't know.
To just go ahead and create this little effect where the fighter kind of moves back and forth. Again, looking at the inspector here, you'll see that the translation is not changing at all. However, the rotation is changing every single frame, which in turn is still going to update the local to parent every single frame.
Hmm. This doesn't work because this this doesn't exist anymore. Not a struct transform aspect. Where are my errors? What? What? Where? That's not even being called. fucking. Little world there. It's a 4x4 vector. A local transform is relatively useless. I think it's the rigid, right? Is the one that I'm looking for. Let me close that vehicle authoring, right? Yeah, here. This is useless. Actually, wait. What was this? These are all 0 because they're not being set because you can't set that. There's the rigid transform. Which I think is probably what we want. All right, so if we go back to rigid transforms, position to authoring. Okay, so we've got that, which is a whole bunch of useless information because there doesn't seem to be a way to convert a rigid transform into a world position. Unity dots convert rigid transform into world position. Not real. His stuff relies entirely on something that's no longer in ECS. This entire video relies on something that doesn't exist anymore. It's too old. Either that or he's explaining it in a way that I'm not understanding it. So either way you swing it, it's effectively useless information at this point. It's either it's missing stuff is the problem. It's missing stuff because it's assuming too much. Right? Like it's assuming that I understand more than I understand about it. Are the Wow, he releases a lot of member only stuff. Pretty much all of his new videos are member only. That's kind of a shitty thing to do. I kind of understand his wanting like doing it, but like means that I can't use any of his tutorials. It is what it is. I can't get mad at like I can't get too mad at him like as a whole because like he's gotta pay the bills somehow. And tutorials on YouTube don't pay particularly well, right? And especially in something that's niche because like there's only a certain there's a so Unity devs are a subsection of the world population, right? Unity devs that are looking for dots tutorials are a subset of that already small portion of people in the world. So like I get it. It's right, but like it's just like you're effectively hiding all the tutorials behind a pay gate. And at that point, right, like they better be damn good if you're expecting me to pay monthly for them, right? They better be damn amazing. I think the better way to do it would be like Code Monkey, where he puts out an actual course. If you're gonna lock all of your tutorials behind a paywall, you might as well make it a course. Yeah, no, I like small and concise tutorials, not like overarching like massive tutorials with like lots of moving objects and stuff like that. I kind of tried to make that a little bit in Unreal. What's going on with this? Is 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 this down? Is Discord down? It says that it's not. Let's see if this guy's is out. Yeah, this guy's out too. Okay. Let's see if mine's out. Yeah, mine's out. Yeah, Discord's fucked. Yeah. Yours too? Okay, so Discord is entirely down. Thanks, Discord. Okay, so Unity. Find world position. Unity ECS to world position. Oh wait, somebody suggested a minus instead of a plus. I forgot. I was going to test that. Here we go. This one here. So this is, sorry, this is plus. What we want to do is a minus. And we don't care about this. Wait a second. What? That was weird. I'll show you in a second here. But let's see what happens. That's the start position and it never gets updated. Sorry, it was just the position was like in completely the wrong spot, like really the wrong spot. Local rotation. And then we do local position. I forgot to do this. Local rotation. I appreciate it. Oh, I think we're back up. Yeah, we're back up. Okay. Yeah, that's in a very different location. It's right there. Hmm. Unity is not in play mode. God damn it. Okay, so would this be local to world position minus? Is this has the local rotation and local position? I'm gonna spend the entire fucking day, it looks like, just trying to figure out why I'm not able to get a position offset working. I have a transform, a dots rigid transform with local values. How would I go about converting that to a world position with local values as an offset? How about converting that to a world position? Converting that to the world positions on the world position of a provided based on a provided world position. I feel like the rigid transform holds information that I don't think it's supposed to be. Although that looks correct. That almost looks correct. Minus the fact that it's way too low. This Y is too low. No, it's the front left, right, that we're dealing with? Yeah. Why is this so low? Yeah, it's way too low. Way, 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 way too low. This is supposed to be what, like here. What if I do this? Then we do negative. That looks correct, actually. That actually does look correct. Almost. Oh, thank you for, linking me to a random conversation. And like not even the conversation. Oh, okay. So So I have the position. I rotate. There's no rotation. The world position's wrong. Everything's wrong. It'd be so cool if transforms, like if dots just worked the way that you would expect. If transforms and dots worked the way that you would expect them to, it'd be really nice. Coming down so it feels more like you're working with game objects. There's a reason, and it's probably just because they haven't written enough of it yet. Or it relies around a yeah, but doesn't mean that it's not going to change. So far it looks like there's no way to do this. What is an inverse transform? Also known as an inverse sampling, is an inverse probability into transform method, or the is a basic method pseudo random number sampling. This function is essentially the opposite of transform point, which is used to convert from local to world space. So I want wait. This function is essentially the opposite of transform point, which is convert. So we need an inverse transform point. Unity ECS. We are back. think I'm getting it. I think I'm getting it. What? In it, okay, so we do inverse. And inverse takes in a rigid transform, which is this. Okay, bear with me here. I'm going to do this one more time. Stop and build. I think I know what to do. Hmm. One sec. Okay, so that's relatively correct there. Yeah, there we go. What? Gotta be kidding me. Okay, so if I take this and we look at this in runtime, Mhm. The entity does not exist anymore. Huh. Probably the easiest way is just to convert it to a local transform and use one sec. There we go. Just convert them to local transforms and then Unity dots convert into local transform. Uh, local composition. Uh, okay. was it? It was from position. Cannot access static method from position in non-static context. Oh, wait. This is because, what's this return? This returns a local transform. So this would be a local transform. Wheel local transform. Rigid transform is just a wrapper for position / rotation. I just use the relative POS. Yeah. Hmm. Local transfer. Wait. So inverse. Wait. Transform by inverse of this transform. Transforms a point by the inverse of the transform. Wait, if I do local transform dot. Let me try that actually. One sec. And then we pump in this. Local transform. Local transform. And what's this return back? uh, wait. So here we would take this, pop that down, bring this over here, and this returns back the wheel local transform. There. And this is the wheel local transform here. Local transform. Then this returns back possible impure structure. No, that's not what we wanted. we wanted inverse from point. And this would be this, right? Yeah, and this is a float 3. What's the error? Other than that, this needs to be float 3. And then if we say that this is the ray start, wait, what? That was so wrong, it wasn't even funny. Wait. That's so weird. Transform a point. Transfer a point. Oh, sorry. Transform a transform by this transform. The transform to be transformed. The transform after transform. Transform a local transform by the inverse of this transform. Local transform itself just has all the utility built into it. For example, you can do the maths yourself if you prefer, but I just wish it worked. Okay, so I think what we do is we say fuck it and we do this ourselves because Unity doesn't seem to have built it. And we can do that potentially maybe by doing our creating a we create a where's this local coming from? Hmm. Okay, so this doesn't work. Now, can we do this? So I think we can do this. These are local transforms. Mm, and we take these go in reverse. Right? And then we do this. Oops. Uh, okay, so now I have the vehicle world position. position. Maybe? Maybe now. It might be the other way around too. Mm. What if we do someday this might work. That actually worked a little bit better. It's still wrong, like horribly wrong. It did work a little bit better. Unity dots convert local transform to world transform. Local transform local position. Transform point. Transforms a local coordinate inside this transform into world space. Local to world. Value read only dot. Wait, why is my suspension fucked up? My front my front right suspension's all kinds of fucked up. That one's right. That one's right. Okay. I'm gonna come back to here, and we're gonna change this from instead of a mesh collider, we're just gonna add a box collider. There, that's fine. This way, it just doesn't fall over for testing purposes on this one. There we go. That's way off. Way off. Mm. Yeah, still getting the wrong one. At least, like, the weird part is, at least this is more right than when I do it the way that it probably should be done, which is the inverse of this. Right? Like, if I do this, because I think this is going to give me the really off. This one's the one that goes in reverse. As I go down, it goes up. Yeah. It goes up to roughly the right spot, at least. But it doesn't fall with it. Oh, maybe. Mm, You're gonna probably catch up and then pass me. Yeah, you might. The possibility is not zero. I'm starting to just get irritated though. Wait, wait. Holy shit. I don't have weird offsets anymore. Oh. This is what we need. So we just want transform point. Transform point will give us the world position back of whatever our relative to the local position. So transform point will give us the world position of the float 3 point that is passed in relative to the local transform. Transform point, yeah. So the answer is just to use local. I'll just post this in for you so you have it as well. Anybody in chat wants to see exactly what it is, it's this. That didn't post it to Twitch, did it? No, it did. Okay. Weird. Okay, yeah. We got both. There we go. After all that, now we can start working on applying upward force. Okay, so here's our start, right? Do they have a pure version of it? Whatever, it works. Yeah. Okay, so this would be wheel front left start or position, world position. Let's see if it actually it does. Sweet. Let's make sure that all 4 wheels are in the right spot now. It looks like it, yeah. Yep. All in the right spot. It's beautiful. Okay, so now what we need to do is we need static. Static. Get um nice. Get ray and actually I don't think we need that. Because like the ray positions just like yeah. Okay, so now all we need to do is get the ray offset. This we can do up here. There. Now we need to get the raycast build raycast input. That's what we want. Raycast input. Return new raycast input. I should have copied all of this. This be a float 3, and this be start position. This would be a float offset. And we're going to do a float 3 for normal direction. Oh, and we need the filter. Where's my filter? Collision filter. Collision filter will be filter. Okay, so we're going to delete that. So the ray start will be the start POS, right? And then we will end POS. Add explicit return? What the fuck? We have an explicit return. I don't even understand what they mean. Oh, that was why. That makes sense now. This would be wheel front left ray cast input. Hmm. And this would be wheel front left ray cast input. Okay, and then we do wheel front left raycast hit, wheel front left raycast result dot position, wheel front left world position. Wait, yeah, wheel world position. Wheel front left raycast input dot end. So we can do this, right? Start. What's a position? I don't know if this is it. The point in the quiz. Okay, so it is that. Okay. And then here we would effectively just do this. Yeah. Okay, so this would be this. There. And then this would be but I don't actually want this. I just want these dots. Mm. Okay, so now we can do this. Wait a second. I don't want this. All right, I'm going to be right back. I need food. I don't think it's offsetting correctly. Oh, wait, right. It's colliding on itself. A bitmask describing which layers this object belongs to. Okay. An optional override if if the value in both objects is equal and positive, the object always collides. If the value in both objects is equal and negative, the object. Ooh. So the answer is that at the end of the day, we're going to have to do the configuration on that. But for now, what we actually want to do is do multi-ray casting. Mm, I'll show you. We want this, right? Native list, right? Native list, and the native list is excuse me. Of raycast hits. But I think what we need to do here is Oh, that's why. Wait, what was it? Yeah, Unity physics. Then this. Actually, I think what we could do. I feel like we just want to do this. Okay. Mm, so this has to do with this. Hmm. Mm. So the correct way to do this is to filter itself out so you don't hit itself using the filters. But at the moment, what's more important is, does it actually function the way that we want it to? So at the moment, that's what we want to test for. Hmm. Heard people talk about how much longer it takes to like build Unreal than Unity. I disagree. Unity takes so much longer to load. Look at that. Perfect. It works exactly the way that we wanted it to. All right, give me two. I will be right back. Oh, just got up. The diff between system base and iSystem. He makes an interesting comment on them. Here's the timestamp. Oh, sweet.
We do not extend model behavior. Instead, for a system, we have two possible ways of making them. One way is to make this a class and extend system base inside
Oh, yeah,
unity.entities. This is how you make a system that deals with managed types. So things like game objects, transforms, delegates, and so on. Also note is this needs to be marked as a partial class. This comes back to what I mentioned in the beginning of how dots is very much based on source generation. Basically, we're marking this as partial, and then the dot system will write the rest of the code. So this is one way, making a system base. Like I said, this one is for managed data. And the other way is instead of making a class, we make it a struct. And instead of system base, we implement iSystem. So this one is meant for unmanaged types, so structs, ints, bones, and so on, which in turn means you can use bursts on this one, making it much faster. Basically, by default, you should probably always try to make an iSystem unless you specifically need to use a managed type, in which case use a system base. However, also let me make sure one very important thing about systems in general. Both iSystem and system base, both of them run on the main thread. Just making something a system does not make it multi-thread. For that, we need to make a proper job, which I'm going to cover later on in the video. Okay, so here let's use an iSystem. So it needs to be partial, needs to be a struct, and needs to implement iSystem. Then over here on
Oh, yeah. Yeah, no. It's perfectly valid. Okay, so we can remove this. And then maybe, but like you shouldn't. You should try and keep things you should aim for things to be um yeah, burst compatible as much as possible. Okay, so now we have the move. Target position Y. Ugh. Dots apply constant upwards force on an object. Physics component extension. Apply linear impulse. Mhm. Okay. Now Vehicle authoring. There's a vehicle authoring. Baker. Mm-hmm. Oh, here it is. iSystem. Create a raycast from the suspension point. Calculate a simple slip. Update translation of wheel along suspension column. Remove the wheelbase. Okay. Oh, here we go. This is literally what we were looking for. Calculate and apply impulse. Here's the end result, the result position, current speed. World apply impulse. That's what we want right there. Right there. This is what we want right here. So now all we need to do is adjust this and then we're good. We've got our suspension and we should be bouncy. We should drop down and then go back up and do this. Joy. Finally. I think we're going to be able to do the vehicle mostly today. Calculate and apply the position. Ray end. Ray hit result. Dot position. Current speed up times we up. LV B. Get linear velocity of the ray result rigid body in ray result rigid body index. POS B. Impulse. Okay, what is we up? Which is C up. And C up is and what is T? System get component local transform. Oh my God. T is local transform. Then CE position is the T dot position. I was going to say a graphics thing, but nope, it's just var T. Fuck me. The naming is terrible in this fucking. The example scripts have the worst naming I've ever seen in an example script. It's like, can we get real names, please? Please, like that would be nice. Well, it's like it's an example script, right? Like I completely get doing stuff like this for like this type of stuff. If you're working on a project where everybody involved is working on it together, right? A sample project that goes out on the internet for the sole purpose of teaching people should not have truncated names like this, right? I know now that this is transform, but what kind of transform? It's local transform. This should be more descriptive. I should be able to look at it and know exactly what it is without having to jump around the freaking code base to figure out what this value means, right? And it's just like, this is a little bit stupid, right? There are some things that are entirely okay to have shorthand for. If I'm doing a for loop, right? In this situation, all the context of how I is being used is here, right? When I'm iterating through here, This could be 1,000 lines long. If I come across an I usage in a for loop, I assume it is the index, right? It is assumed, right? Things like that that are so ubiquitous across the languages, completely fine to shorthand, right? Some people will be like, you shouldn't shorthand that even. And it's just like, there's a certain point where it's just like we're getting into the realm of like, maybe the person following this tutorial isn't the right person for this tutorial, right? CE up, I have no context as to what CE means. I literally do not know what it means. I want to say that it's child entity, but it might not be. I actually don't know what CE is. I come up here and I see like there's like we get the vehicle. So now I have to so we get the wheel has a vehicle attached to it. So I jump to this, right? And then it's like, okay, so this is the vehicle. And then how is this wheel being instantiated? So now we have to come down here to figure out where it's being instantiated, right? So, where's that wheel again? There's wheel, wheel here. No, it's not that wheel, it's vehicle. No, it's something entity, right? And this is where I get annoyed. Here, vehicle. Yeah. Okay, so where's this being set? Right? So then we go find usage. And there's more than one usage of this. But I believe that it is this one here. So wheel entity. But that's not it. It's vehicle entity. So it's for each this. So it's the vehicle entity. Yeah, so it's a vehicle entity. And it's just like this is a bit silly. At least if you're gonna do this, like you should have like CE is the XYZ, right? Yeah. C index, which I still don't understand why it's CE. CE screams like child entity to me, but like I don't know if that's correct because it's kind of the parent to the wheel. Right? Anyway, so is it child? I'm just getting annoyed. Okay, so then what is current speed up? Oops, what? There, current speed up. Current speed up is the dot locate, the the dot between the velocity at wheel and the we up, which I believe is the wheel entity up, but it's actually the CE up, which is the child entity up. So we're adding extra confusion here. But what's the wheel velocity? Where's that set? And what's that set at? World get the CE index and then the wheel position, and we get the linear velocity of I hate it. Okay, so let's go to something that doesn't have silly math. YouTube.com. So we know how we're going to apply the force. So now that we know how we're going to apply the force, what we can do is we can they look like toys in this. Anyway, sorry. We can since we know what we're going to be like how we're going to be applying the force, now we can go to that like video that I've got cached from like last week. Custom vehicle system. This one's still good, but it's not the one that I'm looking for. This is the one that I want.
Set up to work out a spring force. Now, first thing to realize about a spring is that a spring has a rest distance. It has a length that it likes to be. And then if you compress the spring, it will push back to go back to the rest distance. Or if you stretch the spring, it will pull back to go back to that rest distance. And so the first number that's involved in this calculation is going to be the offset, which is basically just how far away are we from that rest distance. Now notice that this offset needs to be a signed value. So on one side, it needs to be negative, and on the other side, it needs to be positive. And this number is telling you which way to go and how far to go to get back to the rest distance. And actually, if you want to calculate a spring force, that's really all you need. You need to know the offset, and then you...
So the offset is where the raycast hit, and then the strength is the strength of the spring. Yeah.
Multiply that by some value that says how strong is this spring. So here's a quick example where we set the strength to 10, and if we push the spring and then let go, you can see this green line. Let me scale it down so it's easier to see on the screen. The green line is the force we're calculating, and the force is literally just the current offset times some number, which represents the strength of the spring. So when we're pushed all the way here to an offset of -0.4, then our force is -4, and if I stretch the spring the other way, we get a force just as strong in the opposite direction. And then you can start playing with values like this value for strength. What if we beef up the spring and give it a much thicker metal coil? Now you can see the force is a much higher value, and that results in a much faster oscillation. So the first step to calculating a spring force is just to calculate the offset and multiply it by the strength of the spring. That gives you a force that you can apply directly. But you might be noticing that this spring seems to just bounce back and forth forever. And that's true. If you just have this much information, you get a spring that will bounce forever. Now, real shocks on cars and other kinds of springs have what's called a damper. It looks something like this. It's sort of like a plunger of some kind, and there's some fluid. And then this thing doesn't want to move. So when you try to push the spring now, it has to push the plunger through that fluid, which is resisting motion. And so that's literally what damping is referring to, is trying to slow down the motion of the spring. So we can represent this in code if we know one other thing, if we know the current velocity of the spring. So imagine the spring's bouncing back and forth. We can stop it at any point, and we can understand the velocity of the object the spring is attached to, in this case, the tire. And if we know that, we can calculate a damping force. So a damping force is basically trying to stop any motion. It wants to resist motion. So that's why you take velocity into account. And so if I give this thing a little nudge here, you can see that it quickly kills any motion. And this is happening with a force that's in the opposite direction of the velocity. So the velocity is headed to the left, and the force is pushing to the right. And the size of the force is sort of relative to how much velocity we have. You can see down there the force is just negative velocity times damping. And again, damping is just some number that we choose. In this case, you can think of damping as kind of representing how thick is the fluid that's inside that damper there. Thicker the fluid, the more it's going to resist motion. So then when we want to calculate a better spring, we combine these two elements. So now our force is equal to the offset times the strength, which is the part that's trying to push the spring back to its rest distance. And then we tack on this damping component that says, but by the way, the spring is resisting motion. And so now when I compress the spring and I let it go, you see we don't oscillate very much. In fact, we come to rest very quickly. So it starts to get a little complicated to look at all these arrows and kind of like really understand what's happening. But if I slow down a little bit, you can see that at the beginning here, when the spring was squished and we let go, that we have our offset is pretty big, and that times the strength is giving us a lot of force, saying go to the left. And right now our velocity is pretty small.
Okay, so this is the amount of force that we're pushing on the vehicle.
So it's not doing much. But as we speed up here and we head towards the home position, look at that, our green force actually flips directions. And despite the fact that the spring still needs to go to the left to reach its rest position, our ultimate force right now is pushing in the other way. It's trying to slow this thing down, slow down, slow down, slow down. So that's the damping force counteracting the regular spring component to keep this thing from oscillating over and over again. And what's great about this is once you've got this formula, it's just 4 numbers, offset times strength minus velocity times damping. 2 of these numbers are numbers you just decide, the strength and the damping. And you get very different behaviors depending on what you set these numbers to. Here's an example of a spring with a strength of 100 and a damping of 1. So this thing is going to bounce back and forth a lot because the damping is very small. It has a small effect on the system. This would be like a spring with a really thick coil of metal and maybe just air inside the plunger. Now, what if we change this and we say the damping is 30? We took the air out of the plunger and we just poured a bunch of honey in there. And so now this spring really is not going to want to move. So even if I compress it down and let it go with the same strength coil, it has to try really hard to push that spring because it's really resisting any kind of motion. And maybe somewhere in the middle, let's take out that honey and put oil inside, and now you get something that doesn't resist it too much. Let's it get right back to the rest position, but doesn't overshoot very much. And so these are 2 numbers that you can then tune to get a spring to behave exactly how you like. Now, one thing to keep in mind is that these numbers are relative to the mass involved. So imagine you had a really weak spring and you put it on a car, the car would just slam down to the ground because it was so heavy. Similarly here, depending on the mass of the objects that you're trying to affect with the spring, you might have to make the strength and the dampening bigger or smaller depending on the mass involved. So here we have again our final formula for a spring force, and this is what is called a dampened spring force because it has the damper involved. But basically it's just 4 numbers. You got to work out the offset, how far away are we from our rest distance, multiply that with the strength of the spring, and then subtract the velocity of the thing the spring is attached to, in the direction of the spring by the way, times the damping, and then you get a spring force. So this is all we need to calculate that green force on our car. And here's a look at the actual code for the suspension force, and as you can see this...
Add force at position. This is all we wanted.
compression ratio between 0 and 1.
Okay, so get point velocity, higher transformed opposition. Ooh, excuse me. There's the vehicle body. Vehicle body. Get component vehicle body. So what we want is we want to system get component, and we want to get the CE, which is the vehicle, and then we get vehicle body. I want the rigid body, right? Get rigid body. Yeah. Do we have the rigid body? I didn't CE index my ass. Sorry. Okay, then we can do get the rigid body vehicle. Is that right though? Let's see if we get any errors on this. Hmm. We don't get any errors around it. Sweet. So we have the rigid body now. So since we've got the rigid body, we can do result.rigid body index. Get linear velocity. No, we've got the linear velocity. It's in physics velocity dot value RO dot linear velocity. This is our linear velocity. Get point velocity. Higher transform position. Would this be our rigid body? Sorry. Vehicle rigid body. Right. So if we do vehicle rigid body dot get linear velocity at point. No, it's get point. Is this not what I think it is? It's a rigid body. Raycast hit. Wheel FL. Ray results, right? Ray results 0. Sorry, wheel raycast results dot rigid body index. And then that's velocity. What does this tell us? Gets the linear velocity of a rigid body at a given point in world space. The world to act on. Zero-based index of the rigid body at point. Okay, so what we want to do is, what we want to do is we want to um, uh, we want to take the first rigid body that we hit and we want to save that only, right? So we want to take a yeah, actually give me 1 second. I want to see something. Because this here is kind of like the question here. What we essentially want to do is we want to say only collide with everything except for yourself, right? Create union. Test if the collision filter is considered equal to another. Get hash code. Create union. What if I did this? So this is based off of the rigid body, I think. Definitely coming back to this. I have to do a little bit more research. Results. And then what we'll do is we'll create a temporary unity dot physics dot raycast hit, and we'll say wheel front left raycast result. If it's let's rename this to hit. If hit dot sorry if wheel fl raycast result, if check if wheel if wheel raycast result is not is null. That's not what I asked to do. I said is null. So this would give me a null value, right? So if I do if wheel raycast hit is equal to null, right? This would be valid, right? We do wheel fl hit equals hit. Is unity null? Oh, actually, you know what? We'll just do this. Oh, that's why. My bad. And then we'll just break. The only reason why I don't want to do it right this moment is because I have to go in and like fix the layers for everything, and I don't want to do that right this moment. Okay. Yeah, I have to. Sorry. I'm fairly certain that I have a layer mask for everything, right? Layout? No. Did I not do a layer mask? I thought I did. There was an easy way to get to this. Yeah, drivable. Right, so I have the drivable thing. And that will allow me to say, hey, only detect for drivable stuff. But I haven't tuned drivable yet for the vehicle. So everything is effectively yeah. I don't entirely understand how this is going to work yet. Because like the chassis itself is stuff and whatnot, and I don't know. Okay, so then we would do wheel FL raycast result dot raycast result dot raycast result or yeah, hit result, and then this would be position. But I don't think that's correct either. Okay, this is ray.end. This is ray result position. So we do ray result position minus ray end. And what we want is we want the tire transform.app, which is going to be the vehicle up, right? So this would be local, world transform. I feel like it's world, local to world dot value read only dot up. Float 3, spring up direction. And then we would have world space velocity of the tire, which we don't really have. But we have Right, because the tire doesn't move yet. Mm. Spring direction times force times tire position. Force is the offset times the spring strength minus the value times the spring dampening. Calculate the velocity along the spring direction. Note that spring dir is a unit vector, so the result so this returns the magnitude of the tire wheel velocity as projected onto spring. To calculate offset from the raycast is suspension rest distance minus tire ray dot distance. It's just the velocity of the tire that I don't really have because that's an up and down velocity, right? We need to figure that out. Based off of like hmm. I'm not sure if it's just me or my camera feels like it's lagging. Wow, movement's blurry. Interesting. I'm looking at it in it's not Twitch. I think it's OBS. Or it's the camera. There might be something wrong with the camera itself. Could be the ISO. Oh, you know what? It's probably the ISO. One sec. Let's see if that fixes it. Maybe? Still a bit blurry. Still have 16 terabytes. It's not a space problem. Yeah, and it's just the camera, so it's definitely a problem with the camera. I could cycle the camera, see if that fixes it. Maybe? Still a bit like it's yeah, no, it's definitely slow. It's not been like this all the time, right? Like I'm not crazy. Feels like it's super slow. It's blurry as fuck though. Yeah, no, it's totally just today. Yeah, no, it's showing up on the camera like that too for some reason. Huh. Weird. Really, really, really weird because it's not been doing this. And today it's like really bad. At this point, oh well. oh, oh well. Hmm. So uh figure out the how to figure out the velocity of an object. We don't have time. Um Unity dots get velocity of object. Velocity towards a point? Yeah, we can get time, but like that's not necessarily the answer. We need to figure out the velocity of the wheel, right? Based off of like where it's going. How to figure out the velocity of a spring. Maximum displacement of a spring from its equilibrium position. Spring constant, a measurement of the spring's stiffness. the mass attached to the spring, the time at which you want to calculate the velocity. Mhm. So the issue that we're having that we're going to have is that we don't have a we don't have a body that is like we don't have a body that's displaced. We don't have a point that is being displaced in a direction for the wheel. I need to fix that camera. It's actually starting to bug me. I noticed it and now I can't not see it. Motion, slow motion. Blurry motion. Oh, you know what? There we go. I fixed it. Nice. Fuck yeah. Oh, wait. All right. So I figured out what the problem was. Um, the little wheel that I've been spinning is changing the shutter speed. And I thought it was changing the ISO. Oh well. I don't. Okay, so 500's got a weird thing. Mm, There. Maybe that will work. That's really fast. Shutter speed. It's really bad. There we go. That's better. Okay. So we need to find a way to have a value that has a has physics. Okay, so is it possible to find the average velocity over the entire time in the 2 points? Is it possible to find the average velocity between 2 points by calculating the displacement change in position between those 2 points divided by the time it takes to make that displacement? Essentially, the formula is velocity equals final position minus initial position times final time minus initial time. I will be right back. That's my mostly dead coffee. That is a 27. Hmm. Ah. Calculate the velocity. We choose some speed s, then the direction of the player from the overall speed their velocity to give us the speed. So now the enemy will fly at the same speed directed towards the player, but if the player is near the enemy will overshoot and keep bouncing back and forth over the player. So we limit the speed. So we need the position of the object itself. Okay, so I really need to figure out how I'm gonna how I can fix the green screen lighting. It's because there's a window right behind the camera, so the lighting's changing throughout the day. Um, we need another offset, is what it is. Okay, so we need an offset from the position of the we need the wheel position, right? We have the suspension start position, but we need the wheel position now. I feel like this had it in uh here we go. From suspension from chassis. So we need the wheel, we need the information of the wheel, where the wheel is relative to the suspension. And then we have the strength. And then we can use the strength to adjust where that is. Okay, so the nice thing is that we've done so much work on this that we have a general idea of how this will work. Here's our system. That's fine. This here, what we want to do is not using baking info. Not even using this. Okay. This is the wheel position. We're actually going to have this here. And these are going to be the suspension points. Wait, do these entities? Returns an entity allocated with a game object. With a game object. Game object whose entity is requested. The flag indicates that the entity requires the necessary transform component to be moved at runtime. I feel like these need to be entities. There we go. And these I want to actually change the name of because these are backwards. Rename. Rename. This I want to change to from suspension to wheel. Okay, so now we get this, right? And then can we do get transform from entity? This is vehicle configuration dot value read only dot wheel front left. Get all entity options. No, that's not it. Entity manager. Okay, well, what we're going to do is we're going to do this. And then it's It's system API dot get component. Local transform. Maybe? I convert local transform. No, I want local transform. Wheel front left local transform. Can this be updated then? I like dots. Dots is great. Dots is a bit of a pain to deal with sometimes. What do you mean it's not being used? It's definitely being used. Never mind, it's not being used. Uh, can we write to this? Interesting. We can't write to it. Let's see. Cannot apply. Oh, right. Opposition. Hmm. All right, let's try this. Let's see what this does. Now, what I expect this to do is just go all the way down, just end and then not stop. That's what I want. That's what I'm hoping it will do. So I just want it to point down and just go. Actually, I think it's going to go up because I think I just gave it the up vector. I didn't negate the up vector. No, there's nothing, no impulse is actually being done. We're just merely checking what's going to happen to the transforming question. If we ever stop loading, we will get to try and find out what happens to this transform location. There we go. I think I've got the wrong thing here. It helps if I do this right. We have learned nothing apparently. This is what we want. uh, wheel new. Excuse me. All right, let's see what happens. Oh, interesting. It firmly stopped. I'm not gonna lie, I wasn't expecting that. It adjusted though. That's kind of the wait. How does this work? I think so if I do this, green, we say 10. Go back to 5, right? And all we want is the we just want this, and this is red. There. So now we have the green is going to be where our wheel is supposed to be, and the red is where our spring location, like our spring home location is. And then we realize that we did that. By the way, our calculation for where our spring is supposed to be is wrong. Because the spring location should be the max, right? The spring point should be the max of where it can be, not the middle, not the rest point. But that's fine because I don't mind that being off right now. We can adjust that later because we've figured that out. Oh yes, it is always wrong. The question is it this? It is this. Oh my god! But that's wrong. It's this. Uh, we need. Yeah. Okay. Hmm. It's always off, but only because it's supposed to be always off at this point. I think that's interesting. It's interesting that it has a stop. Like I'm curious as to why it has a stop. And I think it's because it's relative and it's only it's like it's a weird relative. What are the other options here? Indicates that this that an entity requires the necessary transform. I think the answer is actually renderable, not dynamic. There we go. There we go. Now, if I come down here, and we add these wheels back, we hit play. What happens? Does the wheel move? I feel like the answer is yes. The answer is no. The wheel is not moving. Okay, we figured out part of it. We figured out part of it. So happy. Get entity. Returns an entity associated with an object. She is found. So this is where this comes in. We add the entity components. These are wheel game objects. Okay, so we effectively did this. Now we need to do this. Sort of. Mm. All right, we're going to do this tomorrow because I need a break. All right. Well, thank you to everybody who showed up and stuck around. It was good chatting with you again today, Chrono. I will be back again tomorrow for another good 7 to 8 hours. And we will get some more of this done, and hopefully we will have the car physics, the basic car physics at least working tomorrow, hopefully. That is the plan, the hope, the dream. We'll see if we get there. All right. Catch you later. Ta-ta for now.